So next we'll be covering the logical database architecture, under which we'll be covering the table and the data types, the default rules and constraints, indexes, views, store procedures, functions, and triggers. All the data in SQL Server database are contained in objects called table. Each table represents an entity. SQL Server table has two main components. One is columns, which is called the attributes, and other is a row. Each column represents some attribute of the object model by the table, and each row represents an individual occurrence of an object model by the table. Data types. One of the properties of the column is called a data type, which defines the type of data the column can hold. Default rules and constraints basically help in maintaining or imposing the data integrity in the database. Default specifies what values can be used in a column if you do not specify a value for the column while inserting a row. Default can be anything that evaluates to a constant, such as a constant or a built-in function, anything. Rules are for backward compatibility feature that perform some of the same functions as check constraint. Check constraints are preferred and standard way to restrict the values in a column. Check constraints are also more concise than rule. That can be only one rule applied to a column, but multiple check constraints can be applied. Check constraints are specific as a part of the create table statement, while rules are created as a separate object and then bound to the column. Constraints allows you to define the way Microsoft SQL Server automatically enforces the integrity of the database. Constraint defines rules regarding the values allowed in column and are the standard mechanism for enforcing integrity. So this kind of enforcement is called generally the domain integrity. Using constraint is preferred to using triggers, rules, and defaults. The query optimizer also uses constraints definition to build high-performance query execution plans. Classes of these are the types of constraints. We can have a not null, a check constraint. Not null specifies that the column does not accept the null value. Null is not equal to blank or zero. Null generally refers to something as unknown. Check constraints enforce domain integrity by limiting the values that can be placed in a column. Domain integrity can be achieved using check constraints. A unique constraint enforces the uniqueness of the value in a set of columns. No two rows in a table are allowed to have the same values for the column in a unique constraint. Primary key also enforce uniqueness, but primary keys do not allow null values. A unique constraint is preferred over a unique index. Primary key constraints identify the column or the set of columns whose value uniquely identify a row in a table. No two rows in a table can have the same primary key value. You cannot enter a null value for a column in a primary key. Using a small integer column as a primary key is recommended. Each table should have a primary key. A table may have more than one combination of columns that could uniquely identify the rows in a table. Each of this combination is candidate keys. A foreign key is one table points to a primary key in another table. A foreign key prevents action that would leave rows with foreign key values that there are no primary keys with that value. Indexes. Index is a structure associated with a table or views that speed up the retrieval of the rows from the table or view. An index contains keys built from one or more columns in a table or view. These keys are stored in a structure that allows SQL Server to find the rows associated with the key values quickly and efficiently. There are two types of indexes. One is clustered and the other one is non-clustered. Basically, in case of a clustered index, the data are physically ordered by the key value. Whereas in non-clustered, it's not the case, and I think I've covered this in the previous session itself. Views. A view can be thought of either a virtual table or a stored query. The data accessible through a view is not stored in the database as a distinct object. What really happens when you query a view is the view resolution happens. So whatever the select statement that is being stored underneath the view gets executed. A user can use this virtual table by referencing the view name in the transact SQL the same way a table is referenced. A view is used to do any or all of these functions. Restrict a user to specific rows in a table. Restrict a user to specific columns. Join columns from multiple tables so that they look like a single table. Aggregate information instead of supplying the detail. And also view can be used as a security mechanism where an end user may have access to the view but not to the underlying table. Stored procedures are a group of pre-compiled SQL statements with a single execution plan. Microsoft SQL Server stored procedures can return data in the following ways. We can either have the output, we can make a stored procedure to return an output parameter, which can either be an integer or a character value or a cursor variable. A stored procedure can also return code, which is always an integer, or a stored procedure can also return a result set, which can be used by the front-end application. Stored procedure, again, as mentioned, basically reduces the network traffic, because across the network, all you have to do is just send the stored procedure link, since the code of the stored procedure resides on the server. Second, stored procedure can be used as a security mechanism by which complicated business logic can be implemented within a stored procedure. Also, a user can have only execute permission to a stored procedures, not to the underlying tables. And stored procedures, because the execution plan is already compiled, it yields a better performance when they are executed. Functions is, in programming language, or subroutines used to encapsulate frequently performed logic. Any code that must perform the logic incorporated in a function can call the function rather than having to repeat all of the function logic. SQL Server has got mainly two kinds of functions. One is built-in, which is provided by SQL Server. The other one is a user-defined function, which allows you to define your own transact SQL function using create statement. User-defined function can take 0 or more input parameter and return a single value. One of the main advantages of having a function over stored procedures is function can be used as inline with your select statement, but in case of a stored procedure, you may have to trap the value into a variable and then you can use it. Triggers are special case of stored procedures defined to execute automatically when a DDL or DML changes happens. There are two kinds of triggers. One is the DML trigger, which gets invoked whenever we have an update, insert, or delete statement. And DDL triggers correspond to any DDL events on the DB or server. Triggers are powerful tools that sites can use to enforce their business rule automatically when the data is modified. Triggers can extend the integrity check logic of SQL Server constraint default rules, although constraints and defaults should be used instead whenever they provide all the necessary functionality. One table can have multiple triggers. Create trigger statement can be defined with for update or for insert and for delete clause to target a trigger to a specific class of data modification action. And we can use the if update clause in a trigger to check if a particular column is being modified so that we can make some necessary updation in the system. So with that, I think I mainly covered the topics which I had mentioned. And this is a quick summary about what I have done and what I'm doing. I have about 13 years of experience in IT as a SQL Server DBA developer and architect. I've worked in the US mainly on financial domains and have been in Singapore and India in the past. I have worked with SQL 6.5, 7.0, 2000, 2005, and 2008 versions. I have over about 6 years of experience in SQL Server as a DBA, over about 7 years of experience as a SQL Server developer, and I've worked with business analysts, project managers, architects, network and infrastructure admins, and I have a good client interacting skills. And if there is always a good opportunity, I'm always open to it as long as it's a good role. So you can reach me at venkat_SQLDBA@yahoo.com. Thanks a lot for everyone. Thanks a lot to everyone for joining the